Go through.
Let's start afresh. We'll be fast since you already have an idea. Question number 10 again. It says, for what values of x is y equal to what? To that function minimum or maximum. So you want to ascertain at what points the function is minimum or maximum. So to do this, you follow the following steps. I repeat. Number 1, can you find the first derivative? You get it, right? Find the first derivative, meaning can you derive the function? Number 2, you set the first derivative equal to 0. Set it equal to 0. The first derivative you have found, set it equal to 0. You're following, right? Number 3, you solve for critical values. Solve for critical values. After solving for critical values, number 4, can you find the second derivative? Second what? Derivative, which means you differentiate the function again. And then once you are done finding the second derivative, these are just the steps that you follow. Number 5, you evaluate the second derivative by what?
Hello guys, are you there?
By the
Yes.
critical value. By the critical values, isn't it? You evaluate it by putting the critical values. Now, the decision rule is, if you find that the answer is negative, then this gives you the maximum. And if it's positive, that gives you the what? The minimum. So these are the steps that you follow. Can you find the first derivative of a function? Once you find the first derivative of a function, set it equal to 0, then solve for the critical values.
I thought so.
Then find the second derivative and evaluate it. Then determine whether the function is minimum or maximum. So our first step is to find the first derivative of the function using differential calculus. Our function is x raised to the 3rd degree minus 9x squared plus 15x minus 10. So let's apply calculus to differentiate this function. Using the power rule, you will drop the power 3 times the x to the power 3 minus 1, isn't it?
Yes.
Then you have 2 times negative 9, x to the power 2 minus 1, plus 15. This will just be 15. You just get a coefficient if the power is raised to power 1. And the derivative of a constant is 0. So that you can have 3x squared minus 18 plus 15 equal to 0. This is our first derivative. We have set it equal to 0. What's the next step? The next step is that we need to solve for critical values. For the values of x, this is a quadratic equation. You can want to simplify this, knowing that 3 can get into all these functions. Then you can have a reduced form of this function as x squared minus 6x, because 3 into 18 goes 6 times, plus 5, because 3 gets 5 times 2, 15. All that set equal to 0. Then we solve this function. This is quadratic equation, right? We're solving for critical values. Are there any questions up to here? We want to solve the quadratic function. Any questions?
No, it's on my.
There are so many methods, I said, of solving this quadratic equation. The easiest you could choose is a formula method, which says negative x is given as negative b plus or minus the root of b squared minus 4ac to be divided by 2a, right? We're solving for the critical values. And what is the value of a from this function?
1.
1. The value of b, negative 6.
Negative 6.
And the value of c, 5.
5.
Then you substitute. Negative b is negative 6 plus or minus negative 6. You put in parentheses, you square that minus 4 times 1 times 5, because we are just replacing now by putting these numbers into the formula, 2 times 1. Okay? So now, from here, what do? We need to evaluate and solve. Negative times negative 6 will give us positive 6 plus or minus the square root of negative 36 squared. Negative 6 squared is 36 minus 4 times 1 times 5 is 20 divided by 2 times 1 is 2, right?
Yes.
And then from here, you shall have x equal to 6 plus or minus the root of 16, because 36 minus 20 is 16, all that divided by 2. So we have two values of x. The other one, because there are two signs here, there is positive or negative. The other one will carry positive, the other one negative. So you have 6 plus, what is the root of 16 is 4 divided by 2. Then the other one will be 6 minus 4 divided by 2. 6 plus 4 is 10. 10 divided by 2 is 5, right? X is equal to 5 here. And 6 minus 4 is 2. 2 into 2 is equal to 1, so that x is equal to 1. So the two values of x, the critical values are 1 and x equal to 5. Is that clear now?
Yes.
Yes,
And
it
then
is.
from here, we can easily evaluate these into the second derivative. We need the second derivative. Our first derivative was 3x squared minus 18x plus 15, yeah, equal to 0. We need to differentiate this for the second time to find the second derivative. So when you derive this using the same power rule, you have 2 times 3, x to the power 2 minus 1, minus 18. Because this is raised to the power 0, I said you just get the coefficient. This is a constant. The derivative of a constant is 0. So that your function can be 6x minus 18 as the second derivative. Okay? Now you have the second derivative, yeah? You have the second derivative. The last step is to evaluate into the second derivative, the critical values. So you say, if x is equal to 1, the first critical value, then we shall have 6 times 1 minus 18, which will give you negative 12, yeah? And so you can say, therefore, the function is what? Is maximum at x equal to 1, isn't it? Because if you find the second derivative equal to negative, it's a negative number, that's a maximum for us, yeah?
Yes.
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 And again, if x is equal to 5, then you shall have 6 times 5 close minus 18, so that we can have 30 minus 18. That gives you 12. And this 12 is a positive value. And we say that if you have a positive value on this, when you evaluate the second derivative, then the function gives you a minimum. So you can say that, what are you going to say? You can say therefore that the function is what? Is minimum at x is equal to what? to 5.
Five.
That's that.